Hi guys, and welcome back to Viable Futures. Okay, so I've wanted to put together a video on Tesla for quite a while now, and then an interview dropped with Sandy Munro and Elon onto YouTube today, and there were some really interesting points they discussed. So here is my first Tesla video. The original interview was about 50 minutes long, and I've linked it down in the descriptions. In this video, I've extracted my key takeaways to whittle it down to about 15 minutes or so. For those of you that don't know who Sandy Munro is, he is an automotive engineer who specialises in machine tooling and manufacturing, and is known to take cars apart and comment on how they're made. You can check out his YouTube channel, where he generally has very positive praise for Teslas. Now, one of the questions I always had with Tesla's full self-drive is how it works when road markings have worn off, and what would happen if fake lines or fake markings were sprayed onto roads to try and trick cars. This is what Elon has to say.
For self-driving, even if the road is painted completely wrong, and a UFO lands in the middle of the road, the car still cannot crash and still needs to do the right thing. So, what really matters, the prime directive for the autopilot system is don't crash. That really overrides everything. So, no matter what the lines say or how the road is done, the thing that needs to happen is minimizing the probability of impact while getting you to your destination conveniently and comfortably. But the prime directive, absolute priority, is minimize probability of injury to yourself or to anyone on the road, on the pedestrians or anything like that. So, and it's really, it can't be dependent on the road markings being correct or anything like that. It's just got to be, no matter what, it's not going to crash. But like I said, really, for self-driving, it's got to be, even if somebody tries to trick the car, they do not succeed in tricking the car.
Right.
Because people will do weird things. So it's got to be maintain safety no matter what, and don't let yourself get tricked.
Now, this is a great example of what ARK Invest neatly depicted in this slide from their Big Ideas 2021 presentation, comparing Tesla to Waymo, where Waymo may look on the surface to be further ahead in some scenarios in their autonomous driving, but really they are not at all, and Tesla's system is far more flexible and adaptable. The second interesting point Sandy and Elon discussed was the benefits of the single-piece casting. Now, this is still something traditional automakers still are not doing, and Elon notes that he believes this is due to the inefficiencies and poor communication within the business leadership, which transfers down into the car's design.
First of all, I think you can generally see the errors, the organizational structure errors, they manifest themselves in the product. So, for the sort of wheelhouse areas of the body, there was a lot of engineering done, and there were a lot of right answers to the wrong question. So somebody would say, well, what's the best material to make this little section of the body out of? And what's the right material to make this little section? And I think we've got probably the best material science team in the world at Tesla, and then actually a lot of them also do work at SpaceX as well.
Yeah, I know. I'm coming to that question too.
Yeah, but so the engineers would ask, what's the best material for this purpose, best material for that? And they got 50 different answers. And they were all true individually, but they were not true collectively.
Right.
And when you try to join all these dissimilar dissimilar alloys, and you have galvanic corrosion, so you've got to have better seal, and you've got gaps that you've got to seal, and you've got to join these things, and some of them don't. Some of them need to be joined with rivets. Some of them need to be joined with spot welds. Some of them need to be joined with resin and spot welds. And it looks, frankly, it looks like a sort of bit of a Frankenstein situation when you look at it all together. And it's I can't emphasize enough the nightmare of sealing in between the gaps. That is that might be the most painful job in the whole factory is spackling on the sealant.
Yeah.
And then you have a little. If there's a little error with curing the sealant, or just somebody who's been working for several hours makes a slight mistake, then you've got now you've got an MBH issue because you've got a little hole, and you've got a leak issue, and it's just this is terrible. So, you can muscle through it, and we have, but it's just way better to have a single piece casting.
So this single casting solves so many issues. Tesla was known to have had, and some would argue still have, quality issues. Where other car makers would have gone off and solved the problem via increasing the quality assurance, Tesla has removed the problem altogether by removing the root cause of having multiple parts unnecessarily. And combining parts also significantly reduces the size of the shop floor.
So just having the rear body castings for Model Y allowed us to reduce the body shop by 30%.
Yeah.
So there's roughly 1,000 robots on the Model 3 body line, which, by the way, is also not a figure of merit. You want fewer things, not more.
Yeah.
We got rid of 300 robots just with that rear body casting.
Yeah.
And then when we go to the front body casting, we're getting rid of another 300 robots.
Right.
So when Tesla implements the single front casting as well, the shop floor could be up to 60% smaller with 600 fewer robots. This is a significant reduction in factory sizes and factory infrastructure costs, and this single casting will also reduce the time to manufacture a car. There are just fewer things to put together here. Another key point, which is also underestimated, is to do with the combined and aggregated tolerance of the parts.
If you've got a whole bunch of separate parts and each of them has got a given tolerance, even if that tolerance is tight, and it could be like 0.2 millimeter tolerance, but you've got like 50 parts. Okay, now
you multiply them together.
And
you can't win.
Exactly, and you're going to also have like just variance between cars.
Yeah.
So that's for sure like one of the reasons why it's best to just combine the parts and not have separate parts,
right.
And then also just go for extreme levels of precision.
So for the Model Y, the single casting reduced the number of parts by 79. For these 79 parts to fit together, they would have had to be manufactured to a very tight tolerance. On occasions, there would be times where this would go wrong, and the part would either have to be disposed of, or if it made it into the car, could cause the car to rattle. The connections would likely reduce the stiffness of the car and add weight to the car as well. The interview moved on to talk about the structural battery, and this is another significant point in reducing weight and increasing the car's stiffness, leading to a more enjoyable ride.
The cells today in every car are carried like a sack of potatoes. Exactly. They actually have negative structural value because not only they don't serve to aid in the structure of the car, and they have to be isolated from the rest from the rest of the car. So it's isolated from vibration and shock loads and that kind of thing. So then you've got to put mass into isolating the cells, because otherwise they'll bang against the side of the battery casing, and that's not good.
Yeah.
But by essentially bonding the cells in there, and where the bonding foam serves as both an adhesive and a fire retardant, you basically get two birds with one stone.
Exactly.
I think it'd be helpful to show and tell, because if you say shear transfer, using a steel canister, shear transfer between the upper and lower face sheets, what does that actually mean? Let's show you. This is what happens if you've got just a little floppy sheet, or you just have like a limited number of stringers for shear transfer. You can see it's quite bendy. But as soon as you have a whole bunch of cans or honeycomb or anything like that, and you bond an upper or lower face sheet, it gets crazy stiff. You can't bend, you can just put them together and one thing's floppy and the other thing's stiff as hell. And that's really what you want. And then this will also give the torsional rigidity will be much better. And so if you're trying to improve the ride and feel of the car, you say what's the frequency of this car? Is it like a sort of real bendy spring, or is it tight? And that feeling of is this car tight? Really, if people don't understand why does this car feel better than the other cars, because you've got your natural frequency is high and you've got good torsional rigidity. And then another factor is what is your polar moment of inertia? So basically, to what degree is the mass grouped towards the center as opposed to spread out towards the outside? And you can see this with an ice skater where if the ice skater holds arms out, you rotate slowly, brings arms in, rotate fast.
Right.
That's what's meant by polar moment of inertia.
Exactly.
So it's can you rotate this car fast? You can if you bring the mass to the center.
Right.
But this battery integration into the structure of the car is another game-changing innovation. In a gasoline car, the car uses energy to move the dead weight of the gas around until it's used up by the engine. The car is at optimum efficiency just before it runs out of fuel when it's at its lightest. For a traditional electric car, the weight of the battery doesn't get used up as the energy in the cells decreases. It constantly has the dead weight to move around. What Tesla is doing here is putting the weight, or more accurately the structure of the battery, to use. NIO recently presented on the battery swap technology. A key downside I see to this is that they will be unable to use Tesla's innovation here of incorporating the battery into the car's structure because they are going down this battery swap route. Elon and Sandy then moved on to talk about global EV car sales.
Majority of new cars, when you say crossover point, how are you finding that?
50% of the vehicles are going to be sold are going to be, or more than 50% are going to be pure EV, or they're going to be hybrid. And
I believe like hybrid, like no, for sure. I think it probably 10 years. It's probably majority EV.
Yeah, I truly believe that. But when I brought it out, I mean the analysts. I don't want to get too far deep into that, but analysts were saying, you know, maybe somewhere around 2045 there'll be about 15% EVs and whatnot.
Sure.
And now we're looking at California with 8% right now and going higher.
So here, Sandy is saying that he expects 50% of the cars sold in 10 years' time to be EV or hybrid. Elon then goes on to say that in 10 years the majority of new cars will be EV. If we go back to ARK Invest's Big Ideas 2021 report, they estimate that by 2025, global EV sales could scale to 40 million. In 2020, just over 60 million cars were sold. So by ARK Invest's estimates, in a further 5 years, global car sales would be just under 70% EV. The final section of the interview, Elon gave some insights into his views on short selling.
I've never really been a fan of short sellers. I don't know whether you have a comment on that.
Well, I think that there's very few areas in life where you can sell things that you don't own, and the short selling really where you can sell shares that you don't own. When I said it was vestigial, I meant it came from an era when stocks were traded by people traveling on horseback to exchange stock certificates. And in order to have the transaction speed not take weeks, somebody would say, well, the stock certificate is coming on that horse. I don't have the stock certificate right now, but I promise you that I'm getting the stock certificate, and the rider is going to be here. I'm in New York. The rider is going to be here from Chicago in 3 days, and then I'll be able to give you the stock certificate. Yeah. That's where this whole silly thing arose. Yeah. But then the problem is, like, the way short selling is used today is it's kind of like it's frankly used against the public, and so most people aren't aware that short selling even exists. And then the ones that are, very few of them know actually how to use it. It's basically like 0.01% of stockholders know how to use short positions to get ahead, and it's like, I think, effectively a tax on the public.
So I hope this summary was useful, and please do check out Sandy Munro's page as his videos are awesome. Thanks for watching, and I'll see you in the next one.